Dear students, welcome to the chemistry class. This is our 7th video of the chapter. Today we will deal with the topic reactions in solution. Now what do you mean by solution? Solution is solute plus solvent, and solute means it is the substance which is present in small amount in the solution, and solvent is the substance which is present in large amount in the solution. When these two combine, you are getting a product as solution. Now we know that majority of our reactions in the laboratories are carried out in the form of solutions. So it is important to understand how these are expressed, or how the amount of the substance is expressed when it is in the form of solution. The concentration of a solution or the amount of the substance present in the solution can be expressed in different ways. Out of that ways, we'll deal with the first, mass percent. When we are asked to define mass percent, it can be defined as the mass of solute in grams per 100 gram of the solution. It can be defined as the mass of solute in grams per 100 gram of the solution. Now, there's an example to explain this thing. A 5% solution of sodium chloride. What does it mean? 5% solution of sodium chloride. It means that solution is having 5 gram of NaCl, which is present in 100 gram of solution. So, if we are asked to write the expression for this mass percent, how we can explain? See, we can write mass percent of solute is equal to mass of solute divided by mass of solution into 100. So same example, if you substitute the value, mass of solute is here 5 gram and mass of solution is 100 gram into 100. So when you substitute, and you will get the answer as 5 by 100 into 100 as 5%. So this is how we can calculate or express the mass percent. One more thing we have to keep in mind is the mass of solute and of the solution both should be in the same unit. Whatever you are taking, either in grams or in kilogram, it should be same. Why? Because if you divide numerator and denominator, when it comes same unit, of course you are getting the percentage. Otherwise the unit will change. The next is, with an example or with a problem, we can explain the mass percent. See, how is the question? A solution is prepared by adding 2 gram of a substance A to 18 gram of water, and calculate the mass percent of the solute. Now, which is solute and which is solvent here? A is a solute and it is 2 gram. B, solvent, is here water. Now you have to find out the mass percent of the solute. Which equation or which expression we need? We need the expression mass percent of the solute A. Mass percent of the solute A is equal to, how we will get the equation? Mass of A divided by mass of solution into 100. When you substitute mass of A, you will write here 2 gram, and mass of solution becomes 2 gram plus 18 gram. Why? Because A is the substance which is solute and here water is the solvent. When these two things are added up, you will get the mass of solution. So you have to write mass of solution as 2 gram plus 18 gram. So after substituting, your answer becomes, or the equation becomes, 2 gram divided by 2 gram of A plus 18 gram of water into 100. And substituting, you will get 2 by 20 into 100 as 10%. So this is how we are getting the mass percent of the solute. Next is about the volume percent. Volume percent, how we can define is, it is defined as the number of units of volume of the solute per 100 units of volume of the solution is known as volume percent. So when we are given an example, 5% solution of ethyl alcohol, it means it contains 5 ml of ethyl alcohol as the solute in 100 ml of the solution. So how we can explain or express this volume percent? We can express it as volume percent of the solute is equal to volume of solute divided by volume of solution into 100. This is equivalent to, or this is same as that of the mass percent. So here also we have to keep in mind that volume of solute and volume of solution both should be in the same unit. Then coming to the next concentration of the, or next way is mole fraction. How we can define mole fraction? It is the ratio of number of moles of a particular component to the total number of moles of the solution. The definition is, it is the ratio of number of moles of a particular component to the total number of moles of the solution. That means when you are given an example, or with this example we can understand more. If a substance A dissolves in substance B, so which is the solute and which is the solvent here? If a substance A dissolves in substance B, so second is the solvent here, and their number of moles are Na for first substance A and Nb for second substance, then the mole fraction of A and B both we can find out. And how we can find out with the explanation or with the definition of mole fraction is, mole fraction of A, if you want to find out, you can write mole fraction of A is equal to number of moles of particular component. Which one we need? First one. So number of moles of A divided by the total number of moles of the solution. Solution means here A plus B. Both the solutions, solute and solvent makes it solution. So when we are asked to write the mole fraction of A, it can be mole fraction of A is equal to number of moles of A divided by number of moles of solution. When we write in the number of moles symbol or in the form, we will write Na divided by Na plus Nb. This is the mole fraction of A. So same way, if we are asked to write the mole fraction of B, we can write number of moles of B divided by number of moles of the solution. So the expression can be mole fraction of B is equal to Nb divided by Na plus Nb. So this is how we can find out the mole fraction. So with the problem we can understand more easily. See this problem. Calculate the mole fraction of water in a mixture of 12 gram of water, 108 gram of acetic acid and 92 gram of ethyl alcohol. So 3 components are here making a solution. And you have to find out the mole fraction of out of these only one, that is water. Now mole fraction of water, when you have to find out, first of all what things we need? We need number of moles. For finding out the number of moles, what equation we are having? Mole mass of the substance divided by molar mass of the substance. So this we have learned before. So first one, when we are taking the number of moles of water, how we can write? Mass of water divided by molar mass of water. Mass of water is, how we are getting the mass of water? Mass of water is 12 gram here. In this problem it is 12 gram of water. So 12 gram divided by molar mass. Molar mass we have calculated before. That is molecular mass we have done. That is how we have done? 2 into hydrogen's atomic mass is 1. 2 into 1 plus oxygen 1 into 16. It becomes 18. 18 gram per mole. And substituting the number of moles equation, we will get 12 gram by 18 gram per mole. And both the grams are getting cancelled and you will get the numerator mole only. So it becomes number of moles of water 0.67 mole. Same way we can find out for the next one, acetic acids and also for ethyl alcohols number of moles. Now how we will write for that one? Number of moles of acetic acid is equal to mass of ethanol divided by molar mass of ethanol, which is equivalent to, here how much acetic acid is given, or ethanol is given 92 gram. 92 gram divided by molar mass. You have to calculate, that is 2 into 12 plus 5 into 1 plus 1 into 60 plus 1 into 1, and you will get the answer as 46 gram per mole. And with the simplification, you will get the answer as 2 mole. Next one is the number of moles for acetic acid. So for that, you have to write mass of acetic acid divided by molar mass of acetic acid, and the mass is given as 108 gram divided by 60 gram. How it becomes 60 gram per mole? 1 into 12 plus 3 into 1 plus 1 into 12 plus 1 into 16 plus 1 into 60 plus 1 into 1 is equal to 60 gram. That is, you are doing the molecular mass of acetic acid and getting the answer as 60 gram per mole. And by substituting the value, you will get the answer as 1.80 mole. So all the three components number of moles right now you are having. If you know the number of moles, then only you can write the number of moles of the solution. So all these three you have to add up for getting the number of moles of the solution. So when you add 0.67 mole plus 2 plus 1.80 mole, you will get the number of moles of the solution. So the next step is to find out the mole fraction. So mole fraction, total number of moles in the solution is equal to 4.47 mole. By adding all the three number of moles, you are getting the value 4.47 mole. Next is exit is written. That is actually mole fraction simple. Mole fraction of water is equal to, how we will write? The mole fractions equation was mole fraction of water is equal to number of moles of water divided by the total number of the solution, total number of moles of the solution. And here we are getting number of moles of water as 0.67 mole divided by the total is 4.47 mole. So substituting, your answer becomes, both the moles are getting cancelled and you will get the mole fraction as 0.15. So only up to this is the question asked. Now if you want, you can find out for the mole fraction of ethanol and also for the acetic acid. The same method you have to apply. That is, if for the ethanol you are doing, you have to write ethanol's mole fraction is equal to number of moles of ethanol divided by the total number of the moles of the solution. And you will get 2 mole divided by 4.47 mole. Answer becomes 0.45. And for mole fraction of acetic acid, the number of moles of acetic acid divided by the total number of moles of the solution, which is equal to 1.80 mole by 4.47 mole, and answer becomes 0.40. So this is how we are doing the mole fraction of the components. Next is about the molarity. It is defined as the number of moles of solute dissolved per dm cube. Dm cube is decimeter cube or liter of the solution. It is defined as the number of moles of solute dissolved per liter, you can say. So the molarity depends upon the temperature. Whatever the solution is there, molarity of any solution, it depends upon the temperature. Molarity of any solution is specified for a given temperature also. This is the point we have to remember. Now if we are asked to write the expression for molarity, how we can write according to the definition? Number of moles of the solute divided by volume of the solution in liter or dm cube. And it can be written N by V. N is number of moles of the solute and V is the volume of the solution in liter. Now where this since the number of moles of any substance is related to its mass and the mass, molar mass, hence how we can write the number of moles of solute? We can write number of moles of solute is equal to mass of solute divided by molar mass of solute. And mass of solute we represent with small m or W by capital M. Now molarity of a solution, if in case of the mass we are explaining, how we can write molarity of the solution is equal to mass of solute divided by molar mass of solute into volume of solution in liter. So if the W gram, suppose if we are taking W gram of a substance having molar mass M, capital M, is dissolved in sufficient solvent so as to make the total volume V liter of the solution, then the molarity capital M of the solution is given by. That means you just substitute the values there. Mass of solute is taken as W gram. So W divided by molar mass is capital M, gram per mole, into volume which is in liter. So this expression molarity can be written in the form of W by M into V. W is the mass, M is the molar mass, and V is the volume. And the unit becomes mole per liter for molarity. So this way we can find out the molarity of the solution. Now with an example of problem we can understand it how we can calculate. Calculate the molarity of NaOH, sodium hydroxide, in a solution prepared by dissolving its 4 gram in enough water to form 250 ml of the solution. Understand the meaning of the problem and then we have to go with it. Calculate the molarity of NaOH, sodium chloride, sodium hydroxide, in the solution prepared by dissolving 4 gram in enough water to form 250 ml of the solution. So we know that molarity M is equal to what? Number of moles of the solute divided by volume of solution in liters. This expression we learnt. So according to this, if we are writing, we are having here the mass of NaOH is given. How much mass is dissolved we know. So what we have to write is instead of number of moles of solute we have to write mass of NaOH divided by molar mass of NaOH by the volume of solution in liters. When we know that volume of water is given as, or the solution is given as 250 ml, if you want to convert in liter, of course it can be written as 0.250 liter. So mass of NaOH is equal to 4 gram divided by molar mass of NaOH. How we are calculating is 1 into 23 plus 1 into 16 plus 1 into 1. You will get the answer as 40 gram per mole. Now here molar mass is given. Now divided by 0.250 liter. After substituting and equating, you will get the answer as 0.1 mole divided by 0.250 liter. And again this 0.1 by 0.250, if it is equated, you will get the answer as 0.4 mole per liter, or simply you can write 0.4 capital M. Capital M represents molarity and the molarity's unit was mole per liter. So you can write either mole per liter or capital M. So this way you can find out the molarity of the sodium hydroxide. Next is about the molarity equation. If a solution having molarity M1 and volume V1 and it is diluted to volume V2 so that the new molarity is M2, then the total number of moles in the solution remains the same. So we can write it as M1 into V1 is equal to M2 into V2. This is the expression which we are naming it as molarity equation. So if a solution having a molarity V1 and volume V1, if it is diluted to V2, of course the molarity becomes M2, and that time the number of moles of the solution becomes or remains same. That's why we are getting a molarity equation. Now for a balanced chemical equation involving N1 moles of reactant 1 and N2 moles of reactant 2, for amounts of reactants 1 and 2 reacting exactly with each other, that case we have to write M1 V1 by N1 is equal to M2 V2 by N2. For exact neutralization, VAML. VA is written as what? Volume of first reactant. of an acid having molarity Ma and basicity Na by V ml of a base having molarity Mb and acidity Nb. So we can write the equation as Na Ma Va is equal to Nb Mb Vb. This is how we can write the expression. Or the first one you can use. Next one is about the molality. Molality of a solution is defined as the number of moles of solute per kilogram of the solvent. If a solution is prepared by dissolving n moles of a solute in W gram of the solvent, then how we can write the expression is molality M is of the solution is equal to number of moles of solute divided by mass of solvent in kilogram, and it can be written as number of moles of solute divided by mass of solvent in kilogram as N divided by W. Before in molarity we have written N by V. So this is the difference between molality and molarity. Molality M is equal to, when we are writing N by W, the unit becomes mole per kilogram. Since the number of moles of the solute can be expressed in terms of its molar mass, how we can again substitute the N number of solute? Number of solute is equal, number of moles of the solute can be written as mass of solute divided by molar mass of solute. So it can be written as molality is equal to W by capital M molar mass divided by W, and it can be written as W by small w, that is mass of solute, divided by capital M into capital W, where capital W represents the weight or the mass of solvent in kilogram, mass of solute in kilogram. So with the problem we can understand how the molality can be calculated. The density of 3 molar solution of NaCl is given as 1.25 gram per liter. NaCl is given as 1.25 gram per liter. Calculate the molality of the solution. If molality is equation, we know that number of moles of the solute divided by mass of the solvent in kilogram. So here how much molar solution is taken? 3 molar NaCl solution means what? 3 moles of NaCl are present in 1 liter of solution. Mass of 1 liter is equal to mass of 1 liter, that is 1000 ml of the solution is equal to how much we can write? Volume into density. When we are writing volume is 1000 ml into density is 1.25 gram per ml, and it becomes 1250 gram. So the mass of 1 liter is given. Now mass of 3 moles of solute NaCl, mass of 3 moles of solute is equal to what? 3 moles into NaCl's molar mass becomes 58.5 gram per mole, and the answer becomes 175.5 gram. Mass of solvent is equal to how much will be there? Solvent is what? The water or the solution's mass of 1 liter we have taken, that is the mass of solvent. So how we can write is 1250 gram minus this much of mass, 3 moles. When we subtract, you will get the answer as 1074.5 gram, which is equivalent to 1.0745 kilogram. This mass of solvent if we are having, then we can find out the molality. That is, molality of the solution is equal to moles of solute is 3 mole divided by mass of solvent in kilogram is 1.0745 kilogram, which is equivalent to 2.7579 mole per kilogram, or simply you can write 2.79 molality. Molality is represented with small m. So this way we can find out the concentration of the solutions. Thank you and have a nice day.